this section starts exponent rules for us. First, we have to start with some general information and some vocab words that you're going to see throughout some of the next videos that I post, just so we're all on the same page. So a lot of these I'm sure you're familiar with. This guy right here, if you're like, that's the exponent, you're totally right. Where it gets a little confusing is in the next two chunks. If you remember, the thing that the exponent is attached to, in this case the x, that's called the base. If your brain went, that's the variable, you're not wrong. It's just a little bit more particular because it has the exponent attached to it. Now do remember that the big number in the front of a term is called the coefficient. So those are three terms that you're going to be hearing a lot in the next few videos, including this one. Now, other important distinctions to make before we move forward with exponent rules. The exponent in this case is only attached to the x. These two pieces are separated by multiplication. Sometimes we treat them as one big chunk, like 3x to the 5th, and other times we're going to treat them like 3 and x to the 5th separately. So in this problem, or in this little expression, the exponent only affects x. Now in the next one, because of these parentheses right here, the exponent is going to both affect the 3 and the x. Although the 3 and the x are still separated by multiplication, these parentheses kind of wrap them into one nice package that 5 will eventually affect. Now, the other things as we go forward is that if you do not see one of those big numbers in the front, hopefully you remember that that big number there is a 1. And if you see no exponent, it too is just a plain old 1. All right, moving into our first two exponent rules. These kind of count as what I like to think of the special cases of your exponent rules, negative and zero exponents. Now you may have some experience with negative and zero exponents or no experience with negative or zero exponents. We're gonna start with the easier of the two, which are zero exponents. It's a pretty easy rule. You just have to know this one. Anything raised to the 0 power equals 1. Not 0, which is what your brain might have told you. It's kind of weird. So if you see something like x to the 0 power, the answer is 1. Now there are a couple of different ways that you can arrive at that answer. 0 as an exponent means that there are 0 of those x's there. So the only thing left is that coefficient, which happens to be 1. You can also think of it like other exponents right here. So if you think about how an exponent works, and you can pick any base that you want. I picked 2 because it was small and easy to work with. So you might be familiar with 2 to the first power, which hopefully you know as 2. 2 to the second power, meaning 2 times 2, would be 4. 2 to the third power, 2 times 2 times 2 would make 8. And if you throw another times 2 on there, that would get you to 2 to the fourth power, which would be 16. So this is what I want you to notice. As you move up the ladder, you're multiplying by 2 to get from one step to the next. So 2 to the first times 2 makes 4, times 2 makes 8, times 2 makes 16, and that pattern would continue all the way up. Your exponents are increasing by 1 each time. Now, if you're trying to move down the ladder to get from one to the other, hopefully you notice that you're doing the opposite of that. You're dividing by 2. So 16 divided by 2 makes 8. 8 divided by 2 makes 4. 4 divided by 2 makes 2. And the ladder isn't going to magically switch patterns. So if I do 2 divided by 2, I get 1 as my next answer, which should help prove to you that 2 to the 0 power is going to equal 1. Now you can try that with any number, and that will always work as part of the pattern. Okay, heading back to our examples, again, we have that thing where 5y is all being affected by that 0 power. So technically there's a 1 out in front of here, but the whole thing will magically turn into 1. No matter how crazy or weird the inside of that parentheses gets, like 1,834, x to the 48th, y to the 75th, if that whole thing is being raised to the 0 power, the answer is still 1. This is hopefully one of your favorite topics so far. Now, the only time that this changes is when you don't have those parentheses and your coefficient is something other than 1. This is where that whole separate versus all of it being affected by the exponent thing comes into play. So if I have 24x to the 0 power, notice that the only thing that 0 is affecting is the x. It's not affecting the 24. So the 24 part stays the same. The x to the 0 turns into a 1, and 24 times 1 makes actually 24 as your final answer. Here, you don't see this too often, but it's the same idea. The only thing being affected by that 0 power is the 3x. The 8 is outside the parentheses, so it doesn't get included with that exponent. So we have 8 times the 1 that 3x turns into, and 8 times 1 will just make 8. Now is a great time to pause the video to try these problems on your own. Now, as you're checking your work, if you got 1, 7, and 1 as your final answers, you're in great shape and ready to move on to our next section, which is negative exponents. Now, negative exponents are a little bit weirder. Anything with a negative exponent is going to move to the opposite side of the fraction bar. Now, after moving, that exponent is actually going to become positive. Your final answer is not allowed to have negative exponents. In the math world, they are not considered simplest form. It may seem kind of weird, but a fraction is considered more simple than something with a negative exponent. Please note, this is not a reciprocal. So remember, reciprocal is where the entire top and the entire bottom of your fraction flip. This is not that. What we're going to be doing is picking and choosing which pieces need to move and which pieces need to stay where they are. Negative coefficients do not become positive by moving. So you have never been allowed to take -3 and turn that into a positive 1/3 to make it equal. That's not true. That still doesn't work. Okay, now if we think back to our little table, here's kind of what we're thinking. I threw in these divided by 2's just to save a little bit of time. But if you remember our conversation from the other section, as we move up the ladder, we're multiplying by 2. And as we move down the ladder, we're dividing by 2. We're also taking 1 off of our exponent as we move down the ladder. So you'll see those negative exponents now here. So if I keep following that pattern, this is why these negative exponents work the way that they do. So now, as I did, 8 divided by 2 is 4, 4 divided by 2 is 2, 2 divided by 2 is 1. Now, as I do 1 divided by 2, I start getting fractions. So 1 divided by 2 is 1/2. 1/2 divided by 2, or half of a half, is 1/4. 1/4 divided by 2 is 1/8. 1/8 divided by 2 is 1/16. And hopefully you're noticing a pattern. If you don't, notice that after that 0, these numbers turn into the denominator of your fractions. So think about what's really happening there. This is like 1/2 to the first power. This is like 1/2 to the second power, 1/2 to the third power, and 1/2 to the fourth power, which shows you that negative exponent flipping and becoming positive. It's moving down to the denominator, and that exponent is becoming positive. So that's why this works and where this is coming from. All right, so let's get to it. So this is where I'm going to treat these as 2 separate things. And I like to think of negative exponents as something being happy or something being sad. If it has a negative exponent, it is not happy. If it has a positive exponent, it is happy and totally satisfied right where it is. So this positive 2 right here technically has a positive exponent of 1. You'll notice negative exponents on big numbers, on those coefficients, kind of like this. They don't happen too often in only a couple of our problems, so usually big numbers are happy right where they are. But in this case, that x is unhappy. So I have to move that to the other side of the fraction bar. Now you might be thinking to yourself, wait a minute, there's no fraction here. Technically there is. This is over top of a 1. So we're going to end up moving this x to the -5th to the denominator, and it's going to become positive. So 2 is perfectly happy up there in the numerator, but this x to the 5th is unhappy. So I'm going to move it to the denominator, and it will now be happy again. This is then our final answer. All right, similar on the next one. This time the x to the -2 is unhappy in the denominator. So that means we're going to end up moving this up to the numerator. Now the 4 that it's attached to, but separate, is already happy right where it is. So the 3 up on top is also happy. So the 3 and the 4 aren't going to change. It's not like I'm going to take the entire bottom, move it up to the top, take the 3, move it down to the bottom. So that would be taking a reciprocal. This is not the same thing. So 3 is good, 4 is good, but this x to the -2 is not good. So we're moving that up to the top. All right, similar here. Now I know that this x to the -10 is going to have to move to the bottom. But when I create a bottom, I no longer have a top. This is where that imaginary coefficient of 1 comes into play. I do have to include that in my problem as a placeholder because I have nothing else in that numerator. On the next problem, similar, I have a 1 up in the numerator, and now I'm shifting this x to the -3rd back up to the top. So the 1 was already there. X to the 3rd will move to the top. Now remember, if something has a coefficient of 1, we don't really need the 1. So technically x to the 3rd is the best answer, although this answer is not incorrect. That's okay too. Now, if you do have a group of things to move, kind of like this, it's going to work similarly to this. There's technically a 1 out here in the front, which will hold down the fort in the numerator for us. That whole -7y is going to move to the bottom, and that 1 is going to turn positive. Notice that even though this -7 is indeed negative, that's not going to turn positive. It's a coefficient. We can't just magically turn those positive by switching them around. That's not really how it works. Now here, because this exponent is 1, I really don't even need these parentheses. So the best answer looks like 1 over -7y. If this were any other number, I would need to keep the parentheses, and there would be more steps to my problem, and you'll see problems like that in future videos. All right, let's make these a little bit more complicated, getting lots of parts and pieces, kind of going piece by piece. So what I'm going to do is I'm going to check to see if each piece is happy or sad and move it accordingly. So -8, although it's negative, does not have a negative exponent. So that -8 is perfectly fine right where it is. X to the 6th, that exponent is positive, it's happy, so it too is staying right where it is. However, y to the -4th is unhappy. It's not great up there in the top with everything else, so we're going to move that down to the bottom, and then it becomes positive. All right, similar deal with z to the -3rd, not happy up on top, so we're going to move that down to the bottom and make my exponent positive. All right, similar deal when things are camped out down here at the denominator, you can check things the same way. Now this is our first instance of having a big number with that negative exponent. So technically moving that up to the top, I'd have 2 to the +1 power, which we also know that 2 to the 1st power is just 2, but I'll rewrite my answer once we're towards the end here, once we've checked each piece. So a to the 7th power is perfectly satisfied being on the bottom. The exponent is positive where it is. So it's just going to stay right where it is. Another common error that I see is everybody organizing things that are positive up in the numerator and things that are negative down in the denominator. Not always true. Sometimes things are unhappy in the denominator, so they need to be moved up to the numerator. And some things are perfectly satisfied being down there in the basement. Okay, to rewrite without that exponent of 1, this is a perfectly acceptable answer. Just in most, say, testing situations or online, you probably wouldn't see that 1 there. So the best answer would be 2b to the 9th over a to the 7th, c to the 4th. The order of the letters isn't so important as their position and what their exponent is. All right, looking at the next one, it looks like I'm going to have things that stay in the same place, things that are going to be moving around. I'm going to go ahead and draw my fraction bar to start. All right, I'm going to go piece by piece. This 5 is a-okay right where it is. This x to the -2 is not happy, so I'm going to move that down to the bottom. And then it becomes positive. Y to the 3rd is happy where it is, has a nice positive exponent, so we do not move that piece. Z to the -4th is going to move down to the bottom and become positive. All right, I have another coefficient here of -3. Coefficients are typically written out in the front. That's kind of why I reserved some space there for that, just as a formatting kind of thing. Putting times -3 out here in this on this side is a-okay too. It means the same thing. All right, we have a to the -1 down there in the bottom, so it is moving up to the top with an exponent of +1. Again, you don't need to write that 1, but I'll rewrite my answer in another step. Okay, b to the -5th is going to move up to the top as well. It was unhappy in the bottom. And this c also has an exponent of 1, which will stay positive down there in the bottom. All right, this is a perfectly acceptable answer, but to just make it a little bit more formal without those unnecessary exponents of 1, it'll look like 5y to the 3rd, ab to the 5th, over -3x squared, z to the 4th, c. Again, the order of your letters is less important than what the exponents are and where you put them in your answer. All right, we have one more where we're moving the bigger number, the coefficient. Looks like that's going to take a spot down in the denominator instead of being in the numerator. X to the 6th is going to stay up here in the numerator. It's already positive. Same thing with y squared, also positive, so staying up in the numerator. Z to the -3rd is going to need to move to the bottom. Remember to make those exponents positive after you move them. That's the whole point of moving them, is to make sure that they turn positive. All right, a to the 4th is happy on the bottom. B to the -1 is coming up to the top. And so is c to the -7. All right, when I rewrite my answer, just pretty much to get that 1 out of there, x to the 6th, y squared, bc to the 7th is on top, and 4z to the 3rd, a to the 4th will be on the bottom. We'll eventually be combining these rules with other rules that you'll learn in future videos. Now's a great time to pause this video again and try out these 4 problems. All right, if the answers that you got to these problems are 1 over y to the 12th, 5x to the 4th, -2 y to the 6th, over x to the 8th z, or z to the 1st power, and last but not least 7 y, or y to the 1st, a to the 5th b squared, over 2x to the 3rd c to the 9th. Those would be the correct answers.